The topic of this session is the error estimate for trapezoidal and Simpson's rule. This is a topic in the fourth module, numerical methods of fourth semester BSC complementary mathematics. In this session, we discuss the maximum possible value of error in trapezoidal and Simpson's rule. The error estimate for trapezoidal and Simpson's rule. First, the error estimate for trapezoidal rule. Now, let T be approximate value of integral a to b f of x dx obtained by trapezoidal rule. T be the approximate value of integral a to b f of x dx obtained by trapezoidal rule. Then error is equal to Et is equal to integral a to b f of x dx minus t. This is integral a to b f of x dx. This is the exact value of the integral. T is the approximate value of this integral obtained by trapezoidal rule. Then the error is Et is equal to integral a to b f of x dx minus t. Now, we find the maximum possible value of modulus of Et. That is, we find an upper bound for this error modulus of u of t. Suppose this t is obtained by trapezoidal rule of subinterval length h. If f second derivative is continuous and m is an upper bound for values of mod f second derivative on AB. Then modulus of E of t is less than or equal to b minus a divided by 12 into a square n. So let t be the approximate value of integral a to b fx dx obtained by trapezoidal rule with subinterval length h. Then the maximum possible value of error. So modulus of E of t. This is less than or equal to b minus a divided by 12 into a square. This is an upper bound for the error. Here m is it is an upper bound for modulus of f second derivative on the interval ab. H is the subinterval length that we use in the trapezoidal rule. So mod E of t less than or equal to b minus a divided by 12 a square m. This is an upper bound for the error for the trapezoidal rule. An example. Find an upper bound for error. When finding value of integral 1 to 2 x square dx using trapezoidal rule with subinterval length h is equal to 1 by 4. So we have to find an upper bound for error. When we find value of integral 1 to 2 x square dx using trapezoidal rule with subinterval length h is equal to 1 by 4. So here f of x is equal to x square integral a to b f of x dx. So a is equal to 1, b is equal to 2, and we have given the subinterval length h is equal to 1 by 4. Now we have this f of x is a polynomial, so its derivative is, first derivative is 2x, second derivative is 2, it is continuous on the interval 1 2. F derivative x is equal to 2x, f second derivative x is equal to 2. So this is continuous on the interval 1 2. So an upper bound for mod f second derivative x is, so we have mod f second derivative x is less than or equal to 2 in the interval 1 2. So we can take the upper bound for mod f second derivative x in the interval 1 2. M is equal to 2. So mod f second derivative x is less than or equal to m is equal to 2. Now we have the formula mod E of t. E of t is the error, the actual value of integral 1 to 2 x square dx minus the value that we obtain using trapezoidal rule with subinterval length h is equal to 1 by 4. So mod E of t less than or equal to b minus a divided by 12 into a square m. So this is equal to, now b is equal to 2. So is 2 minus a is equal to 1 divided by 12. H is equal to 1 by 4. So 1 by 4 square into m is equal to 2. So that is equal to 1 divided by 12 into 1 by 16 into 2. On simplifying, this is equal to 1 by 6 into 16. This is equal to 1 by 96. So we have mod E of t is less than or equal to 1 by 96. So 1 by 96 is an upper bound for the 1 by 96 is an upper bound for R. Mod E of t less than or equal to 1 by, that is, if we find the approximate value of integral 1 to 2 x square dx using trapezoidal rule with subintegral length h is equal to 1 by 4, then the error et. So mod E of t is less than or equal to 1 by 96. Error is less than or equal to 1 by 9. 1 by 96 is an upper bound for error. Next example, find an upper bound for the error incurred in estimating integral 0 to pi x sin x dx with the trapezoidal rule with n is equal to 10 steps. Find an upper bound for error incurred in estimating integral 0 to pi x sin x dx with the trapezoidal rule with n is equal to 10 steps. Here, integral a to b f of x dx is integral 0 to pi x sin x dx. So f of x is equal to x sin x. A is equal to 0. Integral a to b 0 to pi. B is equal to pi. Here we are given the number of steps in trapezoidal rule. So we have the relation between the subinterval length h and number of steps. H is equal to this b minus a divided by n. This is the relation between the subinterval length h and number of steps n. So this is equal to pi minus 0 divided by 10. This is equal, so h is equal to, here h is equal to pi by 10. Now f of x is equal to x sin x. F derivative x is equal to x cos x plus sin x. F second derivative x is equal to, it is cos x minus x sin x plus cos x. This is equal to 2 cos x minus x sin x is continuous in interval 0 pi. Sine and cosine are continuous. So f second derivative x is continuous in the interval 0 pi. Now we have to find an upper bound for mod f second derivative x on the interval 0 pi. So modulus of f second derivative x is equal to modulus of 2 cos x minus x sin x. Now we have modulus of this is less than or equal to modulus of 2 cos x plus modulus of x sin x. by property of modulus, mod 2 cos x minus x sin x less than or equal to modulus of 2 cos x plus mod x sin x. Now that is less than or equal to 2 mod cos x plus mod x into mod sin x. Now we have the maximum possible value of mod cos x is 1. Maximum possible value of mod sin x is 1. In the interval 0 pi, maximum value of mod x is pi. So this is less than or equal to 2 into 1 plus pi into 1. Maximum possible value of mod cos x is 1. Maximum possible value of mod sin x is 1. In the interval 0 pi, maximum possible value of mod x is pi. So this is equal to 2 plus pi. So we can take m is equal to 2 plus pi. M is an upper bound for mod f second derivative x on the interval 0 pi. M is equal to 2 plus pi. Now we have the error mod e of t. This is less than or equal to, it is the actual value minus the value that we obtained by trapezoidal rule. So mod e of t less than or equal to b minus a divided by 12 into a square m. So this is equal to pi minus 0 divided by 12 into the value of which that we obtained is pi by 10. It is pi by 10 square into the value of m that we obtained is 2 plus pi. This is equal to pi cube into 2 plus pi divided by, it is 12 into 100. This is pi cube into 2 plus pi divided by 1200. This value is 0.13285. So we have mod e of t less than or equal. So this is less than 0.133. So we obtained an upper bound for error. That is, modulus of error is less than or equal to 0.1. So an upper bound for error is 0.133. Now if the number of steps is n is equal to 100, instead of n is equal to 10, if the number of steps is n is equal to 100, then this mod e of t, it is less than or equal to b minus a divided by 12 into a square m. Here h is equal to b minus a divided by n. It is pi minus 0 divided by 100. It is pi by 100. So this is less than or equal to pi minus 0 divided by 12 into pi by 100 square into the value of m that we obtained is 2 plus pi. It is equal to pi cube into 2 plus pi divided by 12 into 100 into 100. So this value is 0.001325, which is less than 0.00133. So if n is equal to 100, that is if we use 100 steps in trapezoidal rule, then the error modulus of E of t is less than or equal to 0.00133. If n is equal to 10, error is 0.133. Upper bound for error is 0.133. So if n is equal to 100, the error is considerably reduced. It is less than 0.00133. Next example. The value of ln2 can be calculated from integral. ln2 is equal to integral 1 to 2 1 by x dx. So we have integral 1 to 2 1 by x dx is integral 1 by x is ln x. We apply limit is equal to ln2 minus ln1. ln1 is 0. So the value of this integral is integral 1 to 2 1 by x dx is ln2. Now the question is, how many subintervals or steps? How many subintervals or steps should be used in trapezoidal rule? To approximate the integral with an error of magnitude less than 10 raised to minus 4. So we want the magnitude of the error mod E of t less than or equal to 10 raised to minus 4. For that, how many steps or how many subintervals are needed? That is the question. Here, integral a to b f of x dx is equal to integral 1 to 2 1 by x dx. So f of x is equal to 1 by x. A is equal to 1. B is equal to 2. Let n be number of steps. Number of steps or number of subintervals. Then we have h is equal to subinterval length. H is equal to b minus a divided by n. This is equal to 2 minus 1 divided by n. This is equal to 1 by n. Subinterval length h is equal to 1 by n. Now here f of x is equal to 1 by x. F derivative x is equal to minus 1 by x square. F second derivative x is equal to 2 divided by x cube. The first we want to find an upper bound m for mod f second derivative x on the interval 1 2. So we have 2 by x cube takes maximum value of it is 2 by 1 cube in the interval 1 to. So 2 by x cube, this function takes maximum value at 1, 2 by 1 cube, minimum value 2 by 2 cube at 2. So 2 by x cube, this is a positive function, takes maximum value of 2 by 1 cube, which is equal to 2. So we can take m is equal to, m is equal to 2. Now we have the magnitude of error, mod e of t. This is less than or equal to b minus a divided by 12 into a square. So this is equal to 2 minus 1 divided by 12 into, value of h is 1 by n, a square is 1 by n square, into m is equal to 2. So this is equal to 1 by 12 into 1 by n square into 2. This is equal to 1 by 6 n square. Now another question, we have the magnitude of the error is less than or equal to 10 raised to minus 4. So we have mod e of t, it is less than or equal to 1 by 6 n square less than or equal to 10 raised to minus 4. Magnitude of error is less than or equal to 10 raised to minus 4. So that this implies 1 by 6 n square is less than or equal to 10 raised to minus 4. So this is equal to 1 by 10 raised to 4. So this implies n square is greater than or equal to 10 raised to 4 divided by 6. So take a square root, n is greater than or equal to 100. This 10 square divided by root 6. It is 100 divided by root 6. Now the value of 100 divided by root 6 is 40.83. So to obtain the magnitude of error mod e of t less than or equal to 10 raised to minus 4, we have to use number of steps n or number of subintervals n. It is greater than or equal to 40. That is, so we can take n is equal to 41. So if we use trapezoidal rule with the number of steps 41 or more than that, number of steps n is equal to 41 or more steps, then the magnitude of the error mod e of t, that is less than or equal to 10 raised to minus 4. So the value of n is, we can take this, n is equal to 41. Next is that the error estimate for Simpson's rule. Error estimate for Simpson's rule. So let S be approximate value of integral a to b f of x dx obtained using Simpson's rule. S is approximate value, then error is equal to ES is equal to integral a to b f of x dx minus s. So this is the error in Simpson's rule. This is the exact value. Integral a to b f of x is exact value. S is the approximate value of this using Simpson's rule. Then this difference, that is the error for Simpson's rule. Now, if f4, this fourth derivative of f is continuous on AB, and M is an upper bound for modulus of f4 on AB, then the error estimate for Simpson's rule is modulus of E of S, magnitude of the error. Mod E of S is less than or equal to B minus A divided by 180 into h raised to 4m. Here h is the subinterval length that we use in Simpson's rule. Magnitude of the error, mod E of S less than or equal to b minus a divided by 180 into h raised to 4m. So this is an upper bound. This is an upper bound for the magnitude of error. B minus a divided by 180 h raised to 4m. Example, find an upper bound for error. In approximating integral 0 to 1 5x raised to 4 dx using Simpson's rule. With number of steps n is equal to 4. So we have to find an upper bound for magnitude of error in Simpson's rule. So we have here integral a to b f of x dx is integral 0 to 1 5x raised to 4 dx. So f of x is equal to 5x raised to 4. A to b 0 to 1. A is equal to 0. B is equal to 1. Here we have given the number of steps n is equal to 4. So the relation between the subinterval length h and number of steps n is h is equal to b minus a divided by n. It's equal to 1 minus 0 divided by 4. It's equal to 1 by 4. So here h is equal to 1 by 4. Now we want to find an upper bound for modulus of fourth derivative of f of x. F of x is 5x raised to 4. So f derivative x is equal to 20x cube. F second derivative x is equal to 60x square. F third derivative of x is equal to 120x. F fourth derivative of x is equal to 120. So it is continuous in the interval 0 1. It is a constant function. So we have mod f4x is less than or equal to 120 in the interval 0 1. So we can take m is equal to 120. Upper bound for the fourth derivative of f of x. M is equal to 120. Now magnitude of the error for Simpson's rule, mod E of s is less than or equal to b minus a divided by 180 into h raised to 4 m. So that is equal to 1 minus 0 divided by 180 into h is equal to 1 by 4. 1 by 4 raised to 4. M is equal to, we can take M is equal to 120. It is 1 by 180 into 1 by 4 raised to 4 is 256 into 120. So the value of this is 0.002604. So it is less than, which is less than 0.0026. So we can take the upper bound for the magnitude of error for Simpson's rule. Mod E of s is less than or equal to 0.00261. So this is the 0.00261 is an upper bound for the magnitude of error for Simpson's rule. With this example, the fourth module is now finished.